Hey guys, thanks for liking, subscribing, sharing, commenting, referring these videos. Now, real gas behavior. In this, we will talk about van der Waals equation and some few important equations coming out of it, like virial equation. So the aim here is to derive virial equation and to learn more about van der Waals equation. So what is van der Waals equation? Van der Waals equation is P plus n square A divided by V square V minus NB is nRT, which you can write as P plus A upon Vm square molar volume square. Vm minus B is RT. Okay, if we ignore the term Vm, I can just use simple P plus A by V square V minus B is RT. So I'm assuming V is same as Vm. It's basically I'm taking molar volume because number of moles I'm considering one in this question. Great. So let's do one thing. Let's do some maths here. So what you can do is P plus A by V square can be written as RT upon V minus B. So let's write that and send A by V square on the other side becomes RT upon V minus B minus A upon V square. Okay, great. Now let's multiply the whole equation by V by RT. So what will happen? This becomes PV upon RT, whereas this becomes V upon V minus B and this becomes A upon VRT. I hope you agree with this. Please check this much. Okay, fine. So let's proceed further. PV upon RT is equal to, now let's modify this, 1 minus B upon V. Can I write like this? Okay, now this term is 1 minus B upon V raised to power minus 1 minus A upon VRT, and this can be expanded with the help of Taylor's expansion. Now I'm not using word. Normally we say like we can open it up. So I'm just using word Taylor's expansion, and then based on that what result we can get? 1 plus B by V plus B square by V square plus B cube by V cube and so on minus A upon VRT, right? So if you open this up, collect the terms of 1 by V together, it becomes 1 plus B minus A upon RT times 1 by V, B by V whole square, B by V whole cube, B by V whole 4 and so on. Okay, those who have problem with Taylor's expansion, we can say 1 minus B by V raised to power minus 1. Normally you expand exponentials, so you use 1 plus nx plus n minus 1 upon factorial 2 x square, all those things. Same thing I'm applying. So this is PV by RT. Okay, so if this term is 0, look at this, all these terms are positive. B by V and B and V both are positive quantities, so B is positive, V is positive, so B by V is positive, though it will be a fractional term, right? It's a very small term. And as you know, when I increase fractions power, so we are increasing fractions square, fractions cube, fractions power 4, definitely what will happen? It will make even smaller number. Okay, so if you can do one thing, that these all numbers are very small, they are approaching towards 0, and if you can say somehow this number is 0. So when will this number be 0? When B minus A by RT is 0, which means T is equal to A by RB. And this temperature is a special temperature called Boyle's temperature. So we have a name here, Boyle's temperature. Okay, so represented by TB, T Boyle's. At this temperature, this term will become 0. All other terms are very, very small. So we can say the value of PV by RT is approaching towards 1 plus almost all are 0, 0 things, right? They're all almost 0. So we can say this is approaching towards 1, which means it is approaching towards ideal gases, and hence we can say when the Boyle's temperature is achieved for the long range of pressure, real gases behave as if they are ideal. So PV equals nRT or PV equals RT becomes valid. And the equation which we are getting at this place, this is considered as virial equation, even this one also. Okay, this is called virial equation. I hope you understood this video. Keep liking, commenting, subscribing, sharing. Thank you very much.